So one of the last topics in 3.1 is what we talk about, find the probability of the complement. So there's this word complement that we want to talk about, the complement of an event. So the definition is down here. The complement of event E is the set of all outcomes in the sample space that are not included in the event. The complement of the event is denoted as E prime. So the Venn diagram at the left, well, I'd actually show a Venn diagram. The relationship between the sample space and E and its complement E prime. So in a sample space, I could have a die. It's like 1, 2, 3, 4, 5, 6. What I could say is the event E is going to be the sample space, the set of 1 and 2. So E prime would be what's not in the original event, which would be then the set of 3, 4, 5, and 6. So when we talk about the complement of an event, we're talking about the big sample space, but then you have the event is going to be a subset of that sample space, and the complement is going to be what's not in the event, but is in the actual sample space, the big experiment sample space. So we have that kind of notation here. Now, when it gets into probability, we can look at an example here. For instance, when you roll a die, let E be the event. The number is at least 5, and the complement of the event is going to be the number less than 5. So in other words, E is going to be 5 and 6, and the complement is going to be what's less than 5 would be the 1, 2, the 3, and the 4. So using the definition of the complement of an event and the fact that the sum of the probabilities of all outcomes is 1, you can use these formulas below. So notice that, if I was looking at this event right here, the probability of E would be 2 out of 6. The probability of E prime, the complement, is going to be 4 out of 6. Now, if you go probability of E plus the probability of E complement, or the complement of E, I should say, that's going to be 2 out of 6 plus 4 out of 6. Notice that's going to be 6 out of 6. That's going to be the whole sample space. In other words, that's got to equal 1. So when we talk about the event and its complement, they will always add up to the whole sample space. In other words, the probability will be 1, because each one is going to be a subset of the sample space. Now, if I manipulate this, notice how if I subtract the P of E to their side, you'd have the probability of E equals 1 minus the probability of E complement, or E prime, which is the complement. So the probability of the complement is going to equal 1 minus the probability of the actual event. So we have these formulas that we can use. These two are probably the most common that we may deal with, is we're going to probably have this one subtracting one or the other, depending on the situation. So a complement is sneaky because I don't think of the complement when I do word problems, but the complement is a lot of times used to save time. So if we go back up to this example here, right here, let me clear off some of my scratches here. Okay. So that's a little bit about the complement. So the frequency distribution shown below, what we want to do is find the probability. Notice how it says find the probability. So notice how we have this frequency distribution thing. This is kind of our empirical probability. So we want to find the probability of selecting a social networking site user who is not 23 through 35 years old. So notice that if I did this, what I want to do is exclude this right here. So what I could do is add these frequencies together, and that would be the event. So the probability of E, which we're saying is not 23 years old would be the probability of 156 over the total frequencies to 975, plus then the 254 over the 975, and then the 195 divided by the 975. So I'd have to do all that math there. What I can also do is I could also do the complement. The complement of this is going to be 1 minus not 23 years old. So 1 minus not 23 years old. So another way I could do this would be 1 minus, and what I threw out actually could put that in place here. And what I'd be doing is when I do not this, if I subtract that from 1, my math would now take on this 312 over this 975. So I'd have this math here. So if we can slide this over, you can kind of see there's 2 ways to do this problem. Let's see if I can find that again. I should have paused my video. So if I look at that first one, notice how I have I can do some parentheses here. 156 divided by 975. If I add to that, the 254 divided by the 975. If I add to that, the 195 divided by the 975, that would give me the probability of not being 23 to 25, because that would be everything else. Notice that the other way we could do this would be just to go 1 minus not 23 years old, which is the 312 divided by 975. I should say that actually is 1 minus being 23 to 35 years old. This should not be the word not there. Let me see here, enter. Notice that we get, did I type something different there? Hold on, I must have done something wrong here. So let me pause this to see what I did wrong there. So when we're doing this, it looks like I left off the 65 and over up here. So this should still be plus, let me get this out of the way. Give me some room here. So I should have also had this 58 divided by this 975. So that would be what's not in our sample space here. So, but then if I do the complement of that, that would be 1 minus this 312 over 75. So if I come back up here, since I've just forgot one thing, if I move up my arrow, hit enter there and copy that down, and just add into that the 58 divided by the 975, because that's the one I left out. Hit enter. Notice I do get the same probability. So the complement would be just 1 minus, and then I would have to just do this one piece here. So the other side of that sample space. So instead of including these 4, I could go 1 minus the 312, and that would give me the same thing as adding all 4 of those together in that sense. So that's kind of what we're going on there. Okay. So that's kind of what we call complement math. Let's look at one more of those. So we got another question or two. So use the frequency distribution in example 7 to find the probability of randomly selecting a user who is not. Notice how again they use this word not. That's also going to be kind of a clue that the complement is probably going to be involved somehow. We just got to understand what we're dealing with here. And that's where I got to read more closely to what I'm doing. I'm still kind of thinking in terms of numbers and not reading my words. So find the probability of randomly selecting a user who is not 18 through 22 years old. So what they're doing is excluding this one. Now, instead of adding these four together and finding the probability that way, what I can do is use the complement and just do 1 minus that. So the probability of my event is going to be 1 minus the 156 over 175. So that's going to kind of do the opposite of it. So 1 minus, again, we said 156 over 975. So that's how the complement can be used, is actually use that piece of data, because we're supposed to be excluding it, but instead we're going to use it, but we're going to subtract it from 1 to get that answer. So if I can slide this back over. So we're going to have then 1 minus this 156 divided by 975. I'm never sure about when to use parentheses and when not to use parentheses. So a lot of times with my fractions, I'll use parentheses, 0.84. Remember, you also have up here this alpha F1 key. So if I did 1 minus, I can also hit alpha, and then it'll do this little F1 up here, which is a little shortcut table for fractions. If I choose number 1 there, then I can actually type it in as a fraction. And that gives me a fraction, but if I want to change that to decimal, I can hit math, and number 2 will change that to a decimal for me. So that means the answer changed it to a decimal. Plus that would also give me my 0.84. So 84% chance of that being the answer there. So that's kind of how we deal with the complement. So that was 0.84. So one thing you watch out for is this word not. If you see that word not, there's a darn good chance we're involving the complement. So what I got to do is identify what we're looking at, and then we go 1 minus that, and that'll give us what we call the complement. Okay, so I'll stop there on that.